Hello, my name is Professor Angelo Rentis. Welcome to the video that accompanies Module 15, Disinfectants and Antiseptics. Today, we're going to be performing Module 15, which looks at the effectiveness of disinfectants and antiseptics. As the introduction to your module tells you, there are many different types of antimicrobial agents. This very large group can be broken down into two somewhat smaller groups. The one group would be the biological antimicrobials, also known as antibiotics. And the second group would be the chemical antimicrobials, known as the disinfectants and antiseptics. In Module 15, we are evaluating the effectiveness of 12 different disinfectants and antiseptics in their ability to inhibit the growth of gram-positive and gram-negative bacteria. Now you're going to see in just a moment, as I move the position of the video camera, that we are going to be evaluating 12 different chemical antimicrobials. I have dispensed a small amount of each of the 12 chemical antimicrobials into each of these 12 dishes. The names of the chemical antimicrobials are listed in your module, Module 15. However, I numbered them, and so each plate that you're going to be seeing here has a number assigned to it from left to right. The leftmost plate is number 1, all the way to the plate there's the rightmost plate will be number 12. I'm going to read off what each antimicrobial is by number. Number 1 is 70% ethanol. Number 2, 70% propanol. Number 3, 5% phenol. Number 4, 10% phenol. Number 5, 1 molar silver nitrate. Number 6, 1% hydrochloric acid. Number 7, Listerine. Number 8, Lysol. Number 9, bleach. Number 10, hydrogen peroxide. Number 11, tincture of iodine. And number 12, saturated aqueous iodine. I've moved the video camera so that you can now see the remainder of the 12 dishes that I've put out for you. Now, something you should have noticed, in each dish, there are 3 small discs. Each of those discs has been sterilized and is composed of absorbent paper. What I'm going to demonstrate to you is how I am going to transfer these discs to the plates that we need to work with for this module. Now, as described in that lab module 15, we are going to evaluate the effectiveness of each of these 12 chemical antimicrobials against 2 different types of bacteria. One of them is a gram-negative rod, the other one is a gram-positive coccus. The gram-negative rod is E. coli, and the gram-positive coccus is Staphylococcus aureus. Now, previous to starting the video, I had set up 3 different plates for E. coli and 3 different plates for Staph aureus. I took the 3 plates labeled E. coli and I swabbed them. I swabbed the surface of each of those 3 plates from a broth of E. coli. The 3 plates labeled Staph aureus, I swabbed the surfaces of those plates using a broth of Staphylococcus aureus. The other thing I did was I took each plate and divided it into quadrants. What you see here in front of you is a stack of 3 E. coli plates and a stack of 3 Staph aureus plates. Each of the 3 E. coli plates have been divided up into 4 quadrants, and each of the Staph aureus plates have also been divided up into 4 quadrants. Then what I did for the E. coli is I labeled each quadrant with a different number, starting with 1 and finishing with 12. So I don't know if you'll be able to see it on the video camera. This is 1, 2, 3, and 4. This is 5, 6, 7, and 8. This is 9, 10, 11, and 12. I did the same thing for the Staph aureus plates. I numbered each quadrant with a different number from 1 through 12. This top plate from the Staph aureus stack, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
This picture shows the 6 plates. The 3 plates on the left are E. coli plates. The 3 plates on the right are Staph aureus plates.
Now, of course, each of those 12 numbers is associated with one of the 12 disinfectants and antiseptics. As I already mentioned, the number 1 plate here, the one farthest to the left, the one I'm pointing to, corresponds to the number 1 disinfectant antiseptic. The number 1 disinfectant antiseptic on your list in Module 15 is in fact 70% ethanol. Now what I'm going to do is demonstrate how I would transfer the paper discs that have been soaking in each dish of antiseptic disinfectant to the plates. Obviously, what I want to do here is I want to make sure that all 12 chemical antimicrobials end up being put on these 3 plates of E. coli, 1 disc in each quadrant. And I plan to do the same thing with Staph aureus. So how will this be done? Well, I'm just, first of all, going to demonstrate placing the paper discs for chemical antimicrobials 1, 2, 3, and 4 onto the E. coli plate that is labeled 1, 2, 3, 4, and onto the Staph aureus plate that is labeled 1, 2, 3, 4. So in order to do this, I will be using a forceps. The tips of this forceps have been sterilized. And so what I'm going to do now, I'm going to push these plates out of the way. I'm going to grab the first E. coli plate that has the numbers 1, 2, 3, and 4 on it, and I'm going to take discs from dishes 1, 2, 3, and 4 and transfer 1 disc from each of those 4 dishes onto the surface of this E. coli plate. So let's see how this goes. You simply grab the disc, shake off any excess fluid, turn the plate over, and I put the disc right in the middle of the number 1 quadrant. I take the next disc, this one from plate number 2, dish number 2, and I put it in the middle of the number 2 quadrant. I take the disc from dish number 3, put that in the number 3 quadrant, and I take the disc from number 4 and put that in the number 4 quadrant. So hopefully now you can see that all 4 discs have been successfully transferred to this first plate of E. coli. And I'm simply going to do that sort of transfer of discs for all the plates from all the disinfectants and antiseptics. Of course, when I'm done, I want to be sure that I have put the top of each, or the lid of each dish back onto the right plate so that the plates don't get contaminated. And then we'll turn around and take all 6 plates and put them in the 37-degree incubator to grow. And then the idea is that if there is any inhibitory effect of the chemical antimicrobial, it will cause a zone of inhibition around the disc. The zone of inhibition is simply an area adjacent to the disc where there is no growth. The larger the diameter of that zone of inhibition, the more effective the disinfectant antiseptic is against that particular organism. The smaller the diameter of the zone of inhibition, the less effective a particular disinfectant antiseptic is against that particular bacterium.
This diagram shows zones of inhibition using antibiotic discs. Notice the different diameters of the zones of inhibition around 4 of the antibiotic discs.
Okay, I'll finish transferring paper discs to the rest of the plates off camera. And that finishes this module.
Here we see what the 6 plates look like after I am finished. You can see on the left, the 3 E. coli plates have the 12 chemical antimicrobials placed in the appropriate quadrants, and the 3 plates on the right, which are Staph aureus plates, also have the same 12 chemical antimicrobials placed into the appropriate quadrants.